So our first lesson, a review of angles and triangles. We're going to talk about first trigonometry, giving us the reason why we need to review angles and triangles. Or anyone? So what is trigonometry? Guys, anyone to volunteer? So what is trigonometry, guys? We know, of course, that it is a branch of mathematics. A branch of mathematics dealing with that. With what? Guys?
It deals with the sides and angles of triangles po.
Okay, it deals with the
Sides and angles of triangles.
Sides and angles of triangle. In particular, measurements, no? Deals with the study of. Do not chat because I can't see your chat, no? The study of the measurements of their parts. Measurements of their parts. And what parts? Sides and angles. Sides and angles. Okay. Like for instance, you want to, let's say, measure the height of a tree. Let's say we have a tree. Yeah. And you want to measure the size of that, I mean the height of the tree. Let's say that's my tree. And you want to measure this height. Yeah, let's say that's the tree. And the reference point is somewhere here on the ground. Somewhere here. And let's say at a certain point here on the ground, you're going to look at the top of this, this tree. From that reference point. So we have from this, so we form a triangle. No? So an imaginary triangle, forming a right triangle with a vertical distance of or length of the tree. So there is an imaginary triangle. So we can apply trigonometry in finding such height. Okay? So we form a triangle. So that is what trigonometry is all about. So if this is the height, knowing, for instance, this point, the distance of this point from this imaginary line, let's say that is 6, or let's say that is 15 feet. 15 feet, and making an angle of, let's say, this angle is, for instance, 32 degrees, 15 minutes. Yeah. So it is possible for us to get this height of, yeah, that height, no? Okay? So that's what trigonometry is all about. Of course, this is just one situation. Um, Trigonometry can also be what? Can also be uh, a subject or that branch of mathematics dealing with the study of phenomena periodic in nature. Deals also with those phenomena or events or situations, phenomena that are periodic in nature, periodic, repetitive in nature. Like for instance, if you hit a pendulum, so it will swing back and forth. So the motion of such pendulum can be described by an equation that involves trigonometric functions. And you notice that there's no triangle in such motion. No? So what we measure is, for instance, distance travel from one point to another point. And then also you can describe its speed, and it involves trigonometric function. And as I said, there's no trigonometry there. So as long as periodic in nature, you can apply trigonometry. Earth revolves around the sun in a regular pattern. No? So every year, it repeats. It passes to every point where the next year, again, it passes. No? So periodic in nature also the orbit of what? Of Earth around the sun. So that's one thing. No? So again, if I have pendulum, so how does it look like? Uh, a pendulum. Let's make that like this. And then, I don't know if this is a correct one. And there is something circular, no? Oh, let's make that. So let's say this is the pendulum. So it can swing back and forth, no? It can swing back and forth here. Let's say it's somewhere here, or it's somewhere here. Okay? So let's just have imaginary blue. So again, the motion of this, the movement of this can be described by an equation involving what? Trigonometric functions. And there is no such triangle. So in other words, trigonometry is not limited to the study of triangles only, but also to phenomenon or a situation that repeats, no? The pattern is repeated. No? Trigonometry comes from two Greek words. Do you have any idea? Huh? It comes from two Greek words. What are these two Greek words? From two Greek words. What are they, guys? By the way, Miss President, you are the one to call your classmates up for the recitation. Because I'm not seeing you, your names. So, and you have access to your classmates' names. Could you recommend name who is going to answer? Huh? You just call at random. I am taking note of those who are not answering and those who are answering.
Sige po. Magre-recite po si Jomel.
Just brief, just call the name, and then I'll be waiting for him, or I have to respond, to reply. What are these two Greek words? Jomel?
Hello. Yes, that's me. Can you hear me? Am I heard?
Yes.
Okay. So far I remember, trigonometry comes from the two Greek words, which is trigonon, which means triangle, and metron, which means to measure.
Trigonon. And trigonon means what?
Triangle.
And then the other one?
Metron is to measure.
Metron. So we have trigonon, which means triangle, no? And what about metron? Again?
It means to measure.
To?
Measure.
To measure.
Yes. Thank you.
Now, other books make use of other terms instead of metron, metria. If you say metria, it means measurement. So it's just like whether it is a noun, you're referring to a noun, or another noun, but a quantity, and a verb. Metron means verb, no? So it means to measure, while metria means noun and it means measurement. Or if you have the word metrein, so it means what? Metrein means a quantity that is a measure. Metrein. So this means a measure, meaning it's a quantity. Let's say 2 meters, 3 feet, 330 degrees, no? Something like that. It's a measure. But if you use the word metron, it means to measure. Any of this word can be used. No? Trigonon, metron, or trigonon, metria, metrein. You can have that. Or some books just have trigon, which means try. Trigon means try, 3. No? 3. Now, from the first definition that we had in trigonometry, so we say parts, no? And parts can be sides and angles. Now let's talk about angles. So what is an angle, guys? Miss President, you call the name.
Charis Custodio.
Array around its endpoint. It is a combination of two rays that will create a certain angle.
Yes, very good. Ano? Sorry again. A combination of
two rays that will create an angle. Those two rays are called the terminal and initial side.
So rays that it is actually a union, no? A union of two rays. And rays can be considered sides, no? You can have sides or lines. You can also, or segments, no? You can have lines, segments, meeting at a common point at a common point. What is this common point called, guys? This is what? A vertex, no?
Vertex.
Called a vertex. I think I need to put this down. Let me put this down. And then I need also to put this down. So you have this as an angle. So because it's vertex where the two rays meet, so this is the vertex. Let us have a representative point on the ray, P, and let's say this is Q. So this is the angle. And let's call this angle theta. So theta, this is the angle. And if you want to make the measure of it, measure of theta, this is size of theta, no? Or measure of theta. But in trigo, you can have simply theta or simply theta. This, it's all right if you just write theta to mean the name of the angle and the measure of the angle. It's all right. So it's not strict, unlike in trigo, I mean in geometry. So you write it specific like this. Okay. Angles can be classified in different ways, no? One way of classifying angles as to amount of rotation, kinds of angles as to amount of rotation, meaning size, no? As to amount of what? Of rotation. How large is that rotation, no? Amount of rotation. So that is size. Okay, Ms. President, call a name. Ms. President.
Yes po. Damien.
Give me one. So I am specific, I did not say kinds of angles, but kinds of angles as to amount of rotation. So I have a specific reference because you might answer left triangle, Bermuda triangle, if I will not be specific. No? I think I saw that in FB. Kinds of angles, the child wrote left triangle, Bermuda triangle, Ayala triangle.
Acute,
What?
acute angle.
Sorry. Beginning with
Acute.
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 Acute triangle. So this is the acutest angle. Is that so? Acute angle. What is an acute angle? Measures what? Measures between 0 degree and 90 degrees. Na? Another one. This is an acute angle. We have right angle, no? Right angle. Right angle measures 90 degrees. 90 degrees. Number 3, by the way, normally a right angle denoted by a square here. So there are two perpendicular sides or rays. Number 3, guys. Give me 2.
Tawag po ba na isa pa po?
Give me the remaining ones.
Go, Mika.
Obtuse angle.
Obtuse. What is an obtuse angle, Iha?
It measures between 90 and 180.
Yes. Measures between
90 degrees and
90
180 degrees.
degrees and
180 degrees.
180 degrees. This is an example of an obtuse angle. Okay? Another one. Give me one. In elementary, normally you have this, no? But we can also consider what we call zero angle. If the measure of the angle is zero, meaning the rays coincide and one of them that does not move, does not make any rotation. Zero angle measures what? 0 degree. So if I have this, yeah, this is my point, and coinciding there, the other ray. We have what we call straight angle. But do not talk of this angle with your grade 2 or grade 1 siblings, huh? Because to their level, this is not yet appropriate. They don't talk of straight angle. So this measures, we have level of understanding. 180 degrees. So you form a straight line. So a straight line can be considered an angle, no? So imagine, is a straight line an angle? So it's an angle. And the measure is 180 degrees. Last one, we have what we call reflex angle. Reflex angle measures between 180 degrees and 360 degrees. So instead of measuring, for instance, the smallest amount it forms or it generates, we measure this. No? This is what we measure. Instead of measuring this smallest amount that it can generate, no? So that it generates, we call this reflex angle. If this is, let's say 30, the reflex angle is 100, 230, so 330, right? When we take 30, so the reflex is 330. Okay? If this is 40, so this is 310, 320. Okay? If this is 90, so the reflex angle is 270 degrees. Another way of classifying angles as to relationships. Angle relationships. So we can talk of complementary angle. What is a complementary angle, guys? Or call a name.
Enzo.
Sir, dalawa pong angles na
Two
nag-aalok sa
angles
30, am I right?
whose sum is
90 degrees.
90 degrees. Like for instance, 25 degrees, what is the complement? 60 or 55? Is it 55?
65 po, sir.
Okay, so if you have, let's say, 90 degrees as a figure, let's say you have 90 degrees, you divide this into 2, no? Yan. To form complementary angles.
Hello po, sir.
Yes.
65 po dapat.
65. Sorry.
Yes po, 65.
65. Oh. 65. 5 plus 5, 10 plus 60, 70, 20, 90. Okay, so if this is, let's say, 25, this one, so its complement is what? Yeah. If this is 25 degrees, so its complement is 65. So this is 65. Okay? So that angle is 65. Next one. You again. Another one. Iho. Okay, call na another name.
Ryan Miselva.
Supplementary angles.
Supplementary angles. What does it mean?
Two angles where the sum adds up to 180.
So complementary angles. So these are two angles that when you add, giving 180 degrees. No? Already with the other name. So we have what are the examples, Iha?
120 and 60.
120 degrees and
60.
60 degrees. So if you have a straight line, you divide it into two. One is 60, the other one is 20. So if this is 60, yeah, the other one is, and if this is 60 degrees, now the other one is 120. 120 degrees. Okay? The next one, last one. What do you call those two angles whose sum is 360 degrees? Guys, two angles whose sum is, by the way, did I record this, guys? Naka-record ba siya?
Yes, sir.
Yes, sir.
Okay. Whose sum is what? Is 360 degrees. Call again another name.
Si Devon.
Devon. Ganda naman pangalan, Devon.
Yes, sir. Hello, sir.
Give me that term referring
Sir,
to two angles, sum is 360.
Sir, I believe it to be called a full angle.
Like for instance, 110 degrees and 250 degrees.
250, yes, sir.
Is this 360? Yes, 360.
Yes, sir. That's basically sir.
So,
Sir, I think it's called a full angle.
sorry.
A full angle, or I forgot the other term. I think it may be a conjugate angle, sir.
Conjugate. Conjugate. So, you mentioned you do not know, but you know. Were you coached by your sibling?
No, sir. Ako po yung kuya.
So we have conjugate angles. Another term for conjugate angles, we have explementary angles. Explementary angles. So if this is my 110, let me draw 110. I think this does not coincide with the size. Let's draw 110. Paano ba 110? This is 90, mga around like this. So that's 110, no? Yan, around this 110. So let's say, 110. Do you have recitation also when discussed during discussion in GenMath?
Sometimes po, pero usually in the chat.
In chat. Because I don't see the chat. And I do not want so much about PowerPoint presentation. It's math, because in math, I think it's better to discuss things like this. Although I should have done this by PowerPoint, but I did not I don't have prepared one because I left my files in the department. I do not want to type again. It's better to write than to type. It will take much of my time. Okay. What else can we talk about angles? Now, let's now move to triangles. What is a triangle, guys? What is a triangle? Which is the leading role in trigonometry, no? The leading figure. Call a name.
Sam.
Who? Sam?
Yes po. Hello po.
What is triangle? It is a polygon.
It's a polygon with three edges
Of
po
what?
and three
Of
vertices.
how many sides? Huh?
Three po.
Sorry.
Tatlo po.
3 sides. No? Tres. 3 sides. Yan. Let's draw some triangles, no? Like this one. Let's have colored. I love colored. So we have so much colored chalk here. So it's like a colored chalk. So this is what? Ayan, this is a triangle. Yeah. Another one, we have this triangle. It's hard to... Another one, let's have this. Yan. These are some triangles. Now, there are things common to these triangles. These are called parts of a triangle. Main parts. Main or primary. Parang colors, primary parts. What are the primary parts of a triangle, guys? Number one, call a name.
Joseph.
There are three. Three what? Three.
Hello po.
Yes. What are the main parts? Three. What? Three what?
The vertices edges po.
Vertices. Next, there are another three.
Three edges po.
Three edges or sides, no? Three edges or three sides, and then three
Three angles po.
angles. If you connect two of the three vertices, you form a side. If between two sides, we form an angle, and there are three angles formed. Okay. Yeah. So we have this triangle. Of course, this is angle. An angle. This is vertex. And this is a side. What about other parts? They are like accessories. No? They are not readily there, but you can put them in a triangle. We call these secondary parts. What are the secondary parts of a triangle? Guys, because it's going to be time, let me just tell. No? So these are, number one, altitude. Altitude is very important in finding area. No, we need height. So given this triangle, let's say I have this triangle, the height is a line segment drawn from one vertex perpendicular to the opposite side. Perpendicular to the opposite side. So that's altitude. Second one, what else? We have median. Median is a line segment drawn from one vertex to the midpoint of the opposite side. So this is from one vertex to the midpoint, meaning this is equal to this, dividing the opposite side into two equal segments. So that is median. Do we have mean? Is there a mean for secondary parts? Mean, mode. Just median, no? But we don't have mode or mean. Then we have angle bisectors. Angle bisector. There are three angle bisectors, there are 3 altitudes you can draw. There are 3 medians. And the last one is angle, a perpendicular bisector. Perpendicular bisector. Bisector. Okay? Yan. So, let's draw a small triangle showing angle bisector. So this is, let's say, angle dividing into 2 congruent angles. It is a line dividing the angle into 2 congruent angles. No? And then the last one, perpendicular bisector, dividing a side perpendicularly into 2 equal parts perpendicularly there at the point of division. Okay? So line also. So these are secondary parts. Now, if you draw all the 3 altitudes, they will meet at a common point, whether you like it or not. And that common point of intersection, we call that point of concurrency of the 3 altitudes. But you have to extend in case for some triangles, for other triangles, for them to meet, you have to extend. And once you extend, they will meet at a common point. And if you have, in a case of a triangle like this, they meet inside, no need to extend. But if you have a triangle like this pink one, so sometimes you have to extend the altitudes for them to meet. And the meeting point is called orthocenter. For the median, centroid. For the angle bisectors, they meet at a point called in-center. And for the perpendicular bisectors, they meet at what we call a point called circumcenter. Circumcenter because it is the center of the circle, circumscribing about a triangle. The intersection of the perpendicular bisectors. The intersection of the 3 angle bisectors is called the in-center because it is the center of the inscribed circle inside this triangle. Okay? Centroid for the median because it is the center of the triangle. We can also classify triangles. So, depending on the reference. So, kinds of triangles according to sides. According to sides. What are the kinds of triangles according to sides? Number 1, we have scalene. Scalene triangle. A triangle with no equal sides. With no equal or congruent sides. No congruent sides. Congruent sides. So, no congruent sides. So it's triangle. So this is supposed to be not equal to this, not equal to this. Number 2, we have isosceles. Isosceles triangle. This is a triangle with at least 2 congruent sides. At least 2 congruent sides. Are you guys, are you still there?
Yes po.
Because I might be talking and talking to no one. No? So this is an example of an isosceles triangle. So we call this base angles. We call this the base. We call this the leg, another leg. And we call this the vertex. Although, vertex din naman to, kaya lang, I don't know why it has to be labeled thing like this. Number 3, what's the number 3? Equilateral. What is an equilateral triangle? It is a triangle with three congruent sides, meaning all the sides congruent, with 3 congruent sides. Congruent sides. So we have all the sides are equal. So assume this is equal to this, equal to this, equal to this. Meaning all the angles inside 180, no? 60 degrees, its angle inside. You can also classify triangles as to what? As two angles. Kinds of triangles as to sides or according to sides. According to sides, angles, sorry. Angles. So according to angles, how many? Number 1, we have acute triangle, the cutest triangle, a triangle with 3 acute angles. 3 acute angles. A special case of this is equiangular. Equiangular triangle. All a triangle with all angles measure 60 degrees each. No? So these are some examples of acute triangle. Or just one. Or number 2, we have right triangle. Right triangle is a triangle with what? With a right angle. Okay? Yeah. So let's draw a right triangle. Let me draw a beautiful right triangle. Because this is the leading role in trigonometry. And this is an example of a right triangle. I do not know if I will be able to convert this to a perfect one. Let me lasso it and then convert to shape. Let's see. Go, go, go. Yeah, and there it goes. It's now a perfect right triangle. Okay? So we call this the hypotenuse, the longest side. Hypotenuse, longest side, facing the 90-degree angle, longest side. This is a leg and another leg. And if this is, let's say, theta, and this angle is beta, they are complementary. Theta plus beta is equal to 90 degrees. Okay? So meaning they are complementary angles. And I can name it angle C, angle B, I mean point B, then this is point A. So I have triangle, right triangle, A, B, C. Okay. Then the last one, number 3, obtuse triangle. Yeah. This is a triangle with an obtuse angle. With an obtuse angle. Obviously cannot have two what? Obviously cannot have two obtuse angles, no, just one. Cannot have, I can't make it perfect. Yan, this one. Let me lasso it again so that it becomes perfect. Let me see if computer can do that. It can't. Oh, what happened? It modified my triangle. Let me put it back there. It can't. The computer cannot, the Windows or the Microsoft Excel cannot convert it to a nice triangle, one with nice sides. Okay? So these are the three kinds of triangles according to size. Acute, then we have right, and then obtuse. No? Do you have any question, guys? Guys,
None po ata.
wala na. Pinantok na sila.
Ito na to.
Ay, salamat. Tapos na si Kuya Cesar.
May nagano yan.
We have
4 minutes.
no more question, guys, ha? Okay? That's it. So we're done with orientation and angles and triangles.
Kung mga nasa video, under maintenance.
More about right triangles, talk about
Reload kaya.
Pythagorean. Okay, so you read about Pythagorean, huh? What are you going to read, guys? Pythagorean theorem. Yan, Pythagorean. Or mga Pilipino, tayong Pilipino, we pronounce it Pythagorean. But yung mga slang, yung mga Americanized tongue, Pythagorean. You read about this, and then how useful is this? Let's find out, or let's find out how useful Pythagorean theorem in a right triangle. Okay? No more questions? Guys, no more?
Wala na po.
Wala na, because they want to leave now. Where are now I can't see anymore the pictures. Okay, if you don't have any more, so I'm going to stop recording. Okay. So that ends our lesson for today. Tomorrow, next meeting, we'll have. By the way, tomorrow is what? Thursday, no? We will meet tomorrow because we have to discuss culminating project so that you can prepare ahead. Is that clear, guys? Hi, guys.
Yes po.
Okay.
Yes, sir.
Yes po, sir.
Okay. So have a nice day, guys.
Have a nice day po, sir. Thank you po.
Ohoy.
Thank you po, sir.
Thank you po, sir.
Thank you po.
Okay.